So far, I've tried to talk to you about computers and in particular programming languages in general. So all programming languages at once. So now I want to specialize to Python, and to get started, I want to give you a little overview of the Python language. So what are its distinguishing features and things like that? Well, the first thing is a very high-level language. So you have access to a lot of functions that are already implemented in the language by default. So if you want to, for instance, sort a big list of integers, there's already functions that exist within the language that will allow you to do this. It's also a very general purpose language. You can use it to do many different things. And for instance, the platform that I'm using now for this course is written in Python. So this can be used to interact with you. It shows that Python can be used to interact with websites, with users, with text, whatever you want. You can build a website out of Python, but you can also do mathematics with it. It's extremely modular, and these two facts actually go hand in hand. So there is a huge array of libraries that you can use with Python, and those libraries help you call on some extra functionality for your particular application that you have in mind. So it helps separate, if you want, the concerns. So if you are purely concerned with mathematics, you wouldn't care about the libraries that help you build a website. And vice versa, if you're purely concerned with building a website, you don't care about libraries that help you do mathematics. Okay, so it has a lot of libraries, and it's easy to bring in new libraries and ignore some others, basically. Now, another distinguishing feature is that Python puts a huge amount of emphasis on readability of code. So this readability of code is very important. It comes from the understanding that most of the time you write code, you write it to obviously code some algorithm to encode it for the computer, but most of the time when programming is actually lost because source code is very hard to read sometimes. So because this code will have to be read by other humans or maybe yourself in a few weeks or years or whatever. So it's really trying to make sure that the users produce very readable code. There's some sort of flow to it, and you can get very, very clear code that is you just look at it and you know immediately what it's supposed to do. And to help with this, it means that there are no braces and no things that appear in some other languages. So no extra symbols that will clog the reading of the code. And instead, it has to find some substitute to do what the braces were doing in other languages, meaning delimit blocks of code that have that stand on the same leg, if you want, that have the same status. And for this, it uses indentation. So indentation is very important in Python, and a lot of people dislike that about Python. It means that you're essentially marking the blocks by using indentation. So indentation is the fact that you put extra space at the beginning of lines. So you might have a line that starts here, 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 and then suddenly one line starts a bit further down. So if you look on the website we're using now, if you look at the tabs on the left, you will see some indentation in the tabs that help you understand the general structure of the site. Well, it's the same idea in Python. So in Python, you will have some code here, 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 and then suddenly you have to put some indentation to mark that this block here is a sub-block, if you want, of the whole block here that might continue there. So it's important that you understand this indentation concept and that you keep it very consistent, because this is actually useful for the Python compiler or interpreter or whatever to understand what you really meant there. Okay, so what about who invented Python? What about its development? Well, Python was originally invented and developed by Guido van Rossum, who is a programmer who used to work at Google and now works at Dropbox, so in the Web 2.0 companies, if you want. And he has always stated that Python is used extensively at all those companies, and he was himself impressed by how much they were using it. So now Python is at version 3.x, if you want. So this number obviously evolves with time. And, well, it went through, it's the third version essentially. So the first one was released in 94. The second one released in 2000, which comes with major improvements on the language and really helped Python take off. So it's really a testament of its success, the fact that it was only invented in 2000. And version 3 came out in 2008. So unfortunately, version 3 is backwards incompatible with version 2, meaning if you write a program that is valid in version 3, it will not necessarily be valid in version 2. Most programs are, and the conversion from 2 to 3 can be automated. You can have a program that does it essentially. It's not quite right, but most libraries, for instance, written for Python 2 point something, can be converted to Python 3. Now, the fact that Python 3 came out in 2008 does not mean that development ceased on version 2. Actually, it continued, and if you want the ultimate Python version 2 is Python 2.7, which was released in 2010, and that's the one that we're using for this course. So this is actually very important. Whenever you're programming, make sure you're programming for version 2.7. Make sure you're installing something on your machine that's for Python 2.7 and not Python 3, because you will run into problems if you do it that way. Actually, it will be easier for you most likely to install 2.7 because that's still more or less the default a bit everywhere. Okay, so what about the language itself? What it can do and so on. So we saw that there were different aspects of programming that were possible. You could do imperative programming, and that's definitely the aspect that is emphasized in Python. But you can do also functional programming and object-oriented programming, all this in Python. So actually, the size here does not reflect really the capabilities. Python has a lot of object-oriented capabilities, but I'll only talk about those later. So maybe let me talk a bit more about the aspects that are related to imperative programming or just programming in general. So there are many built-in data structures like ints, floats, strings, tuples, and dicts. And there are some different types of actions that you can perform on this data in the spirit of the von Neumann model. So you can evaluate some expressions, you can execute some statements, and you can also package some group of actions into some bigger actions, if you want, called functions and procedures. So that's kind of actions on the data you can do, and you can also do some flow control. So really actions on the data that determines where is the next action to execute. So that's what the flow control is, right? It controls the next action. So what are the different ways of doing flow control in Python? Well, you can do conditionals that we'll see soon. You can also do loops that we'll see in week 3, and generators, iterators, exceptions, and so on. So there are different ways of doing flow control, maybe a bit more than in some languages, and they all have their specific purpose, and I'll emphasize each of those. There is also another type of flow control, which is called short-circuiting, that we will sort of see this week briefly in one of the videos. So you could think of why this is really doing some flow control as well, why this really decides on the next action to execute. Okay, so another aspect of Python that's worth emphasizing at this stage is that there are basically two big modes of interaction that you can have with it. The interpreter, which is simpler to understand and to use, at least for simple programs. As soon as you go for more complicated programs, you will want to use the command line. And the interpreter will only describe now and will only really, this is the only part we'll see now. So we'll see this in week 3 or later, the command line. So this will be emphasized in the first 2 weeks, and I'll use it later on as well to show you examples, just because the interaction here with Python is more immediate and the workflow is a bit quicker if you want. So it's more suited for teaching. Now some more vocabulary associated to Python. So what you will be writing in Python are called programs or scripts. So they are sequences of definitions and commands. The definitions create new data, the commands execute actions on this data. the definitions are evaluated, the comments executed, and this execution takes place in the Python shell, what's called the Python shell. So you interact with the Python core via the shell if you want. And a command or statement tells the interpreter to do something. So an example would be to print something like hello student. That's an action, or that's a statement. And Python at each step manipulates objects. So the data is encoded using objects, and each object has a type. So for instance, these are examples of types. There are int, bool, float, str, and dict that correspond to integers, booleans, floats, strings, and dictionaries. Okay, so but these words are reserved, or at least understood by Python at first, to mean those standard types. And you can combine different objects with operators to form more complicated expressions. And these expressions can be evaluated, so they have a value, and this value is itself an object. So that's for some key vocabulary that's necessary to start working with Python or start reading documentation about it. Now about variables. So variables are used to associate a certain name. So basically this name would be a string with some objects that are in memory. And this operation is to associate a name with an object. It's called an assignment, and it creates a binding. So this is the operation that creates a binding. So we say that afterwards some variable is bound to a certain object. Now the names matter for humans. They only matter for humans, not really for Python itself. You could choose very, very long names for your variables. It would not affect performance of your code in the end. But it does matter for humans. So you have to choose the names carefully. Try to avoid unexpressive names. Try to choose names that really reflect what the variable is supposed to mean. So, for instance, a better name for a variable than R would be radius. That's more precise, and anyone would understand what you mean here. Okay, so if you have to choose a name, I have to tell you what's allowed. And you are allowed many things in a variable name. The variable names are case sensitive, so this means if you use upper and lower case, that matters. And you're allowed to use upper and lower case. You're also allowed to use digits, but not to start, and underscore. So this means that a valid variable name, maybe not the best, would be the variable or the var. That's allowed. Or I don't know, radius 2 would be allowed as well. Radius underscore 2 to signify like the radius squared if you want. So this could be a variable name. Now there are also some reserved keywords that are actually excluded from the valid variable names. And I could give you a list now, but I won't. Instead, I'll tell you that from the command line or from the Python shell, the Python interpreter, you can type these and you will get a list of the valid keywords. And you see here, so valid keywords would be, for instance, for or if, or things that have a specific meaning for Python. Here you see a little hash mark, and this hash mark denotes a comment. Okay, so this is another aspect of Python that's important, is you can comment and you can document your code. So that was for a quick overview of Python, and now we'll look in more detail at different parts of the language.